we have seen how to resolve a vector. Okay, so now we are in a position to resolve a vector along its x and y components, and if it is three dimensional we can resolve it along the all the three directions. So but here we have assumed that this vector is in the xy plane. Okay, so we are resolving in x and y, so the components will be along x axis and y axis only. Okay, we have assumed that this vector is in the xy plane, that's why. Okay, fine. Now we'll see how this is useful to add or subtract two vectors. Okay, so now I'll just take two vectors. Okay, let me just take any two vector in the xy plane we are taking. Okay, let's say this is vector number 1. The magnitude of this one is 10, let's say, and this angle is 30 degrees. Okay, and then take another vector, let's say like this. The magnitude of this be, let's say, anything, let's say 6. Okay, and this angle be, let's say, 60 degrees. Okay, the name of this vector is v2. Okay, now if I have to find what is vector v1 plus vector v2, okay, I have to find the sum of the two vectors, the resultant of the two vectors. Okay, what I'll do, I'll simply first resolve the two vectors. Okay, I'm just making some space for myself. I'll just resolve the two vectors. For vector v1, I can write, for vector v1, it is 10 cos 30, 10 cos 30 I cap plus 10 sin 30 j cap, correct? And for vector v2, how to resolve? We have to find the angle from the x-axis. Okay, so to resolve the vector v2, you can use this 60 degree also, but you can means take the angle from the positive x-axis. This is the angle, so how much is this? This is 120, of course, right? 120 degrees. So this one will be 6 cos 120 degrees I cap plus 6 sin 120 degrees j cap. Okay, or means if you don't want to make it in an if you don't want to take the obtuse angle, what you can do, you can see that okay, this vector v2 is towards this, so the x component of vector v2, x component of vector v2 is what? It is along this direction, right? So just find out how much is this length. So otherwise this is equal to, this is the same as, I'll write 6 cos 60 degrees. This is the length of this one, right? The projection on the x-axis, but this is along the minus I direction, so I'll write minus I here. Simple. So both of the things, cos 120 will also give you minus 1 by 2 only, so it's the same thing basically, plus 6 sin 60 j cap. J cap, you see, it is in the positive direction, right? Its y component is along the positive y, it's upwards, up along the positive y, right? So this will give you, find either of these two, they are the same thing. So this is what? This is minus 1 by 2 I cap and plus 6 into root 3 by 2, that is 3 root 3, right? This much j cap. Okay, and v1, if I put the values, what is it? What is the value of v1 if I put the value of v1? So 10 cos 30 is root 3 by 2, so that is 5 root 3 I cap plus sin 30 is half, so this is 5 j cap. Okay, I've just put the values. So this is your v1 vector. Okay, and v2. Now I have to find v1 plus v2. Okay, so I'll say v1 vector plus v2 vector, add the I parts together. This is the I part here and this is I. So this is how much? 5 root 3 from vector v1 and minus half this much I cap, and here it is plus 5 and this is 3 root 3. So plus 5 plus 3 root 3 j cap. Okay, so now this is a vector. Okay, this is a vector v1 plus v2. What is the x component of the resultant vector? This much. What is the y component of the resultant vector? This much. So this is again a vector. This is the resultant of the two vectors. Okay, let's call the name. Let's say the resultant, I say this is r vector, the resultant of the two vectors. Okay, so okay, now 5 root 3, this is approximately, if I try to find out, the value of this 5 root 3 is going to be how much? So if I try to get an approximate value, so this is approximately 5 root 3, so this is 5 and into 1.7, so it is approximately 8. Okay, it is approximately 8.1 I cap. Okay, and plus 3 root 3, so root 3 how much? 1.7, let's say 3, so 5.1, so this is around 10.1, something like that. Okay, 10 approximately 10.1 j cap. So this is a vector, this is the resultant vector, this is a vector. Okay, so if I try to plot this resultant vector, how it is going to be? This is 8.1 along I, so just take 8.1 here, 10.1 along the j, this is, let's say, 10.1, 8.1, 10.1. So the vector r is like what? This is the resultant of the two. This vector is the resultant. So this vector is the resultant vector, r vector, the resultant of the two vectors. Okay, and yes, okay. Now I have just found out the vector in this. So now what is the magnitude of the vector? What is the length? Okay, like vector v1 was of length 10. The magnitude of the vector v1 was 10. The magnitude of the vector v2 was 6. Okay, and the angles also we knew from the x-axis, it is 30 degree and this is 60 degrees from the negative x-axis, right? Now what is the magnitude? And so I have the vector in this form, the resultant vector, but now what is the magnitude? Obviously the length is going to be what? This is 10.1, so this is also 10.1, so the length is going to be, by simple Pythagoras theorem you can find out the magnitude of the resultant is what? 8.1 square, 8.1 square plus 10.1 square upon root 2, right? Okay, so obviously any vector in this form, I cap j cap form, you can use the Pythagoras theorem to get the magnitude. Okay, for any random vector, a vector, or let's say any random vector, v vector is a I cap plus b j cap. So the magnitude of the vector becomes a square plus b square under root of that, right? Under root of that. This is the, now what is the direction? What is the direction of this vector r? We have to find this angle. If I have to find, to say this angle is, let's say, phi, some phi angle. So you can say tan of phi is what? 10.1 upon 8.1, right? So here only I can say the angle, if I try to write, tan of phi is what? 10.1 upon 8.1. Okay, obviously tan phi is this much. Okay, so that means if you have to find for any random vector in the general terms, if I talk for a vector v ai plus bj, what is the case? It is a along x and b along y, a along x. So the direction from the x-axis, tan of the phi, if this is phi, tan phi is equal to b upon a, right? The y component upon the x component. Fine. Okay.